A woman traveling north at 10 kilometers per hour finds the wind appears, the word appears, very important, to blow from the west. When the woman trebles her speed, the wind appears to blow from the northwest. Find the velocity of the wind. You have two different scenarios. Scenario A is that she's going north at a certain pace, and then scenario B is she trebles that pace. Okay? So here's what we're going to do. Let VW stand for the velocity of the wind. Let VP stand for the velocity of the person. And let VWP stand for the velocity of the wind relative to the person. Velocity of wind minus VP. And then what I'll always do is I'll always get one of them on their own. So I'll get VWP plus VP.
Is VP the wind appears? Or is VW the wind appears?
Wind appears to the person. P is the person and W is the wind. So W stands for wind and P stands for person. Okay? So VWP is velocity, how the wind appears to the person. Now, what we're going to do is we're going to need letters to represent what is going on. Now there's two pieces of partial information. So we're going to split the question in half. Scenario 1, Scenario 2. Now, Scenario 1, the woman is travelling 10 meters per second north. Scenario 2, the woman is travelling 30 north because she travelled her speed. Okay? What we're next going to say is that the woman, velocity of the wind, is going to be AI plus BJ. I'm just picking two random letters to represent the velocity of the wind. Remember, the wind doesn't change in between the two scenarios. Is everybody happy with that? Velocity does not change in between the two scenarios. Now, what I'm going to do next is I'm going to get the velocity of the wind relative to the woman, VWP, for both of them. Now, VWP equals VW minus VP. Scenario A, or scenario 1, is what's going to happen there. It's going to be minus A, yeah? I think. So velocity of woman, VW, so it's going to be AI plus B times J component minus 10J, and what that gets me is the velocity of velocity of wind relative to the woman or relative to the person is going to be AI plus B minus 10J. In scenario 2, velocity of wind relative to the person is going to be AI plus B minus 30J. Now, once you've accumulated this much information, the next part is interpreting the language. The wind appears to blow from the west. When you blow from the west, what does that mean? It means you're going east. Okay? And it also means, regardless of whether it's going west or east, it means you have no J component. B minus 10 equals 0. B therefore equals 10. Okay? Now, what we're going to get next is equals 10. Okay? And now we have to figure out what exactly happens in the next part. Okay, so B equals 10. Now, in the next part, the wind appears to blow from the northwest. appears to blow from the northwest. What does that mean? It's actually blowing southeast. Now, it actually blows southeast. This wind is represented by this triangle because it's going 45 degrees. It's actually traveling, as I said, it's coming from the northwest. That means it's actually traveling southeast. Now, a southeasterly wind is across and down. Okay? Now, I'll give you an example of another southeasterly wind. Another southeasterly wind would be 5i minus 5j. So that'd be 5 across minus 5 down. But when you're comparing them, you can't say 5 equals minus 5. That's impossible. So what you're going to have to do is, for a southeasterly wind, the I component equals minus the j component. So what we're going to do here is we're going to change this around to say that the I component, which is a, equals minus the j component. And what that will get us is a equals 30 minus b. We already know that b is 10. This way a must equal 20, and the velocity of the wind therefore is 20i plus 10j. Now, two straight rows intersect at an angle of 60 degrees. Car A is moving towards the intersection with uniform speed 7.5 meters per second. Car B is moving towards the intersection with uniform speed 10 meters per second. Car A is 375 meters away from the intersection as B passes the intersection. Find the velocity of car A relative to car B. So actually we don't even need to think much about that to do it. Phi A is 7.5 I. Now phi B is a different story. Phi B we need to break up into its components. So what I'm going to invoke here is an alternate angle of 60 degrees. I'm going to use 60 degrees here. And then I'm going to say that it's moving at 10. So this is going to be 10 sine 60 and 10 cos 60. Now what is 10 cos 60? 5i. 5. And 10 sine 60 is going to be 5 root 3. So what we get for the velocity of B is we're going to get 5i minus plus 5 root 3 j. Then upon completion of this, I need to find phi AB, just phi A minus phi B. And then what we're going to get is 7.5i minus 5i plus 5 root 3j, and then that cancels and gets 2.5i. What's it? Minus 5 root 3j. Now, what we're going to do next is we're going to find the velocity car relative to B. How far is each from the intersection at the instant when they are nearest to each other? Give your answer to the nearest meter. Okay. Now, there's two different ways to do this, okay? How far is each car from the intersection when they are nearest to each other? Does it start at the intersection? Okay, so we're going to say 375 meters, okay? It's 375 meters away. So, B is at the intersection, and it's 375 meters away. Upon saying that, what we're then going to do next is we're going to start putting in some angles, okay? So we want the velocity of A relative to B. Now, before we go into this, velocity of A relative to B is going to be 2.5 across and 5 root 3 down. I want two pieces of information. I want to know how fast it's going. What is the velocity of phi AB? So if new Pythagoras theorem there, 2.5 squared plus 5 root 3 squared, put in brackets to make sure you don't make an error. Do you have it? No. And square root the answer. 5 root 13 over 2. You can do a bit better than that. 9.014 meters per second. Okay, can we find the angle? Tan inverse that for me.
73.8979.
Okay, so tan inverse is 5 root 3 over 2.5, and you said the angle x is?
73.8979.
So 73.9 will do us there, yeah? Okay, so 73.9. Now, what happens is, it goes down at an angle. Now this is the velocity of A relative to B. It goes down at an angle 73.9. And then it reaches a point at which it's at 90 degrees, which is here. And then we're asked to find out how far is each car from the intersection at the time when they're nearest to each other. We don't actually have to find out what the closest distance is. What we should be finding out is how far did it travel to get here. So what we're going to do is cos 73.9 equals x over 375. And what is 375 cos 73.9? Have you got it? Is it 103.99? Yeah, 103.99. Now we need the time taken for this. So the time is going to be, it's going to be the distance, which is 103.99, divided by the speed. Remember, we're going, what speed are we going again? 9.014. This 9.0144 is going this direction because the velocity of A relative to B. B is stuck to the spot. And what do we get here when we divide them in? 11.54 seconds. Is that right? Okay, 11.54 seconds. Then finally, we need to find out in 11.54 seconds what happens. A is going to travel. A is travelling 7.5 meters per second. So 7.5 multiplied by 11.54. That's going to give us 86.55. This 86.55 has to be taken away from the initial 375 meters. So what do we say? 375 minus 86.55, and what do you say for that, Gareth? 288.45. It wants it to the nearest meter, which gets me 288 meters. And what about car B? B travels. So B travels 10 by 11.54, which is 115.4, rounds down to 115 meters. And the thing about that is, it started at the junction, so we don't need to do anything else with it.